Hello and welcome to Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering classes by clarity of concept and right understanding. Today in our playlist class 12th physics, we'll study subject electrostatics and today's topic is Coulomb's law, where we will study nature and characteristic of force between two point charges, and we will also learn how to solve numerical problems based on Coulomb's law. Let's start. It was known that there was two type of charge, positive nature charge and negative nature charge, and like polarities repel each other and unlike polarity attracts each other. But due to absence of any measuring instrument, numeric or quantitative measurement of that electric force was not available. But French scientist Charles A. Coulomb in the year 1785 made first quantitative measurement of electric forces between two point charges by his apparatus torsion balance, where the force will produce torsion in string and mirror will indicate amount of torsion or indirectly the amount of force developed between charges. As per Coulomb's law, electrostatic force interaction between two point charges is directly proportional to product of two charges. It is inversely proportional to the square of distance between two point charges, and it also depends upon medium electric property known as permittivity of medium, and electrostatic force is inverse proportional of permittivity of medium. If we combine all three proportional relation together, then single proportional relation will become F is proportional to Q1 Q2 upon epsilon R square. Now all proportional relation can be converted into equality, and if in modern international system unit charge is measured in Coulomb, distance in meter, and permittivity in farad per meter, force in Newton got a constant 1 upon 4 pi, and the force relation between two point charges at a distance r in any medium of permittivity epsilon is given by this yellow highlight. This Coulomb's law is applicable between only two charges, that too of point shape. Physically, if separation between charges is considerably larger than physical dimension of charges, then those charges could be considered as point charges. A spherical charge for all external observation is treated as a point charge acting from its center, and this Coulomb's law is not applicable to distributed charges or more than two charges. Here important thing is that force is proportional to product of two charges. Whether one charge is of small magnitude, another one is of bigger magnitude, the product of two would be the same for both. So force on first charge by second charge F12 or force on second charge by first charge F21 is numerically the same but opposite in direction. Like gravitation force between two mass particle, Coulomb's electrostatic force between two charged particle also acts along the line joining two charges. So both gravitation force and electrostatic force are central forces. For like polarity, both charge positive or both charge negative, this force is repulsive or of outward nature, and that outward nature is indicated by this vector notation by r cap, and both same polarity charge product gives direction plus r outward. Similarly, for opposite polarity of two charges, force is attractive in nature, inward type force, and the direction is given by minus r directions, that is inwards. So for force on second charge by first charge is considered as origin, and the direction which from origin join test position is plus r direction. So for like polarity, repulsive force is in plus r directions, and for unlike polarities, inward attractive force is in minus r direction. And one can easily understand that whether it is repulsive force or attractive force, force on two charges is of equal magnitude and of opposite direction as per Newton's action reaction. So we can say force on two charges are equal in magnitude and opposite in direction, and for like polarity it is plus r outward directed, and for unlike polarity it is minus r inward directed. Now the same direction sense can be represented by a double notation script by position vector, and for like polarity, repulsion force on second charge by first charge F21 is given by this numeric relation, and the direction is indicated by unit vector from position of first charge to position of second charge. So this is force on second charge by first charge, and this is direction from first charge to second charge. Likewise, force on first charge by second charge F12 is directed for like polarity, repulsive in nature, from second charge to first charge position in r cap to one direction. Similarly, opposite polarity charge have attraction force, and here force on first charge by second charge is directed from first charge position to second charge position. So F12 got direction r cap 12. If we have to calculate numerically the force between two charges at a distance r in a certain medium, and if medium is air, then the permittivity of medium air is known as epsilon 0, and its numeric value is a constant 8.854 into 10 to the power minus 12 farad per meter. Here farad is unit of capacitance, and when we replace value of epsilon 0, this numeric figure 1 upon 4 pi epsilon naught is easy to calculate figure, both here 9 and here 9. It is 9 into 10 to the power 9 meter per farad. So for numerical calculation, in place of 1 upon 4 pi epsilon 0, we can use a constant k with numeric value 9 into 10 to the power 9 and can easily perform calculations. If the medium is not air but any other medium, then the permittivity of that medium is replaced by this notation. Here epsilon 0 is permittivity of air, the same constant value 8.854 into 10 to the power minus 12 farad per meter, and epsilon r is called as relative permittivity of medium or dielectric constant of the medium, and green highlighted part here is force in air media. So we can say force in any other medium is force in air divided by relative permittivity or dielectric constant of another medium. Relative permittivity is property of material to get polarized, and all material medium got certain amount of polarization, and this relative permittivity figure is always greater than 1 for all material medium. So force produced in air always decrease in other media as epsilon r is greater than 1, and force is inverse function of relative permittivity. For water, epsilon r relative permittivity is roughly 81. So the force in air will reduce by a factor of 1 by 81 in water. So common salt NaCl, which is bonded in normal air conditions, when dissolved in water will ionize, and Na positive ion and chloride negative ion get separated by thermal energy. Similarly, for all metallic medium, relative permittivity is infinite, and when we replace infinite here, we got that force in conductor metal medium will become 0. So you will find that in all metallic conductor medium there will be no force among charges in electrostatics. Numerical problems practice will enhance our subject understanding. We will explain question first in English, then in Hindi language, and explain answer in a bilingual script. So what is force between two small point charges of spherical shape having charge 2 into 10 to the power minus 7 Coulomb and 3 into 10 to the power minus 7 Coulomb placed at 30 centimeter separation in air? So we have given that first charge is 2 into 10 to the power minus 7 Coulomb, second charge is 3 into 10 to the power minus 7 Coulomb. The separation given in centimeter unit should be converted into meter unit is 0.3 meter, and for air 1 upon 4 pi epsilon naught will be taken as k 9 into 10 to the power 9. अगर हिंदी में प्रश्न को समझें तो हमें दो छोटे गोलीय आवेश दिए हुए हैं, उनके बीच में विद्युत बल निकालना है। पहला आवेश 2.10 की घात माइनस 7 कूलॉम का है, दूसरा आवेश भी धनावेश है 3 इंटू 10 की घात माइनस 7 कूलॉम का। दोनों के बीच की दूरी जो 30 सेंटीमीटर दी हुई है उसे हम मीटर इकाई में जब कन्वर्ट करेंगे 100 का भाग देंगे तो ये 0.3 मीटर हो जाएंगी। और हवा माध्यम के लिए विद्युतशीलता का मान रखने पर 1/4 पाई एप्सिलॉन नॉट को k 9 into 10 to the power 9 रखा जा सकता है। द रिलेशन ऑफ फोर्स इज k q1 q2 upon r square in air, and k is 9 into 10 to the power 9, q1 is 2 into 10 to the power minus 7 coulomb, q2 is 3 into 10 to the power minus 7 coulomb, and r in meter is 0.3. So we have just substitute the values. Now for numeric calculations, one has to separate numbers 9, 2, 3 and perform power calculation separately, and ultimately we got that force is 6 into 10 to the power minus 3 Newton, and since charges have similar polarity, so it is a repulsive प्रतिकर्षण प्रकार का है। Two spherical charges have charge 6 microcoulomb, 6 into 10 to the power minus 6 coulomb, and 20 nanocoulomb, 20 13 to 10 raised power minus 9 coulomb. They have a separation of 20 centimeter and the medium is of dielectric constant 3. Find electrostatic force between them. दो एक समान चालक गोलों पे क्रमशः 6 माइक्रो कूलम्ब और 20 नैनो कूलम्ब आवेश है। इनके बीच में दूरी अगर 20 सेंटीमीटर हो और वो एक ऐसे माध्यम में रखे हैं जिसकी सापेक्षित विद्युतशीलता या परावैद्युतांक स्थिरांक 3 है, तो दोनों के बीच में स्थिर वैद्युतिकी का कूलम्ब नियम अनुसार बल निकालना है। हवा माध्यम में बल की बजाय दूसरे माध्यम में बल एप्सिलॉन आर टाइम्स कम हो जाएगा, तो ये हमारे बल का सूत्र हो गया कि की जगह हमने 9 × 10⁹ एप्सिलॉन आर की जगह माध्यम की विद्युतशीलता 3 रख दी। पहला आवेश 6 माइक्रो कूलम्ब, सेकंड इज 20 नैनो कूलम्ब substituted in place of Q1 Q2 and the separation 20 centimeter in meter is 0.2 meter. And for numerical calculation, let's do significant number calculations. First 9, 6 and 20 got two significant number and at denominator it is 3. This is 2 times square function 2 2 and this is significant figure. Now in several objective examinations we got same power in answer and only the significant numeric figure got a choice. So only this calculation will fetch you the result. So it will enhance your speed of calculation in objective type examinations if answers are given in that particular manner, and most often we follow that practice in our examinations. अगर हम पावर भाग को देखें तो ये -6 और -9 और ये +9 और ये 20 का 10 अगर आप कैलकुलेशन करें तो ये 10 की घात -5 आ गई है। यहाँ क्योंकि हमने 0.2 को सिग्निफिकेंट फिगर 2 लिया था तो ये 10 की घात -1 दो बार 10 की घात -2 हो गई है और ये कैलकुलेशन आसानी से 10 की घात -3 आ गई है। अगर पावर सेम है तो इसे कैलकुलेशन करने की जरूरत नहीं है, और अगर सिग्निफिकेंट नंबर सेम है और सिर्फ पावर कैलकुलेशन देखनी है तो आप ये भी देख सकते हैं और अपनी ऑब्जेक्टिव एग्जाम में स्पीड को बढ़ा सकते हैं। और हमारा आंसर आ गया 0.009 न्यूटन। वी नो दैट a charge is divided in equal two parts, it will produce maximum repulsive force. We have to prove it. How a charge Q should be divided in two parts so as to produce maximum repulsive force. Let two parts of capital Q charges, small q and capital Q minus q, and they are placed in air with separation d, will have force given by the relation F, first charge second charge divided by distance square, and the multiplication will fetch small q capital Q minus q square multiplied by k upon d square. And if q is varied, this force will have this type of variation, and one instant it will become maximum in amount. Now before achieving maximum value, when small q is increased, force is increasing. That means with change of q, change in force has a positive nature. And after this maxima, when q is increased, force will decrease. That means change of q will result in such a change of force which is negative. Between positive and negative, the change is not abrupt, smooth. So at maxima, rate of change of force with change of charge becomes 0. So to prove maxima, we can take first derivative of force with respect to variable small q and put it to 0 for maximum force conditions. And if we solve k upon d square is a constant, and differentiation of this first factor result capital Q and second factor result -2 small q, and if it is 0, it results that small q is half of capital Q. So if charge capital Q is divided in two equal fractions, it will fetch maximum force of repulsion between the two. In some numerical problems, charge amount or their separation or medium is changed, and we have to compare electrostatic forces before and after the change. As in this example, we have two identical shaped spherical charges of charge 6 microcoulomb and charge -2 microcoulomb. Opposite polarity charges are there and they have some distance not given to us. We have to assume this distance, and they are touched, and the contact will shift charges between the two, and after touching they are put at half of previous separation in the same medium. Even medium could be changed, and we have to compare force before and after this change. So in initial condition, the force, let's assume medium is air, is given by this expression. Q1 is 6 microcoulomb, Q2 is 2 microcoulomb, and separation assumed R. So in terms of constant K upon RC, in comparison they will cancel out in comparison. The force will be 6 2s are 12, 10 to the power -12 Newton, and the nature of opposite polarity charge is attraction. Now they are made in contact. So in contact, charge will redistribute since both have identical shape. So for equipotential conditions, two would have the same amount of charge, and as per conservation of charge, the sum of charge after contact and sum of charge before contact would be the same. Before contact, one is is plus 6 microcoulomb, second is minus 2 microcoulomb, and the sum is plus 4 microcoulomb. And if they equally divide, then the two charge after contact would be having value plus 2 microcoulomb each. So the new force after the change with half of previous distance and new value of charge 2 microcoulomb each would have value 2 to the 4, and this 4 of r by 2 square when comes in on top will become 16 unit. Multiplier is same, 10 to the power minus 12, and this constant k r square 10 to the power minus 12 will cancel out, and force has a ratio 12:16 or 3:4 in numeric values, and the nature is now the two charges are of same polarity. New force is repulsive, those earlier it was attractive. There could be one negative sign also in this ratio because two forces got opposite directions before change and after change. Take a textbook problem. Suppose two spheres A and B have identical size and identical equal amount of charge, and they have a force F in air media. A third sphere of identical size but uncharged is brought in contact with the first, and after this contact this third sphere is brought in contact with second sphere and finally removed. So we have again only two sphere A and B after touching third sphere, and we have to find out new force of repulsion between A and B in terms of earlier force F. Let two sphere have identical charge small q and separation r, and in air media as per Coulomb's law force would be F is equal to k q1 q2 upon r square, and two charges are equal, so it is k q square upon r square. When sphere A is touched by uncharged sphere C, the charge of sphere A will divide equally among two, so new charge on sphere A would become q by 2, and charge on sphere C, which was earlier 0, become q by 2 now. Now this charge sphere C is again touched to sphere B having charge capital Q, so q and q by 2 now divide equally between sphere B and sphere C, and both have charge now 3 by 4 q. So now after touching action, sphere A have a charge q by 2 and sphere B have a charge 3 by 4 q, and new force would become 3 by 8 kq square upon r square. Kq square upon r square is previous force F, so new force is 3 by 8 F.
This learning video on Coulomb's law has explained each and every aspect of this topic. Now you understand nature, characteristic of Coulomb's law, and you can also solve related numerical problems. We have tried to remove all sort of confusions that ensure high success rate in examination. If you liked our study material, do share it with your friends, and if you want to get these study notes and need additional online and offline classroom interaction, do join membership of our Sridevi Classes YouTube channel. Thank you very much.